Hello, in this paper we present STPOTR, a simultaneous human trajectory and pose prediction using a non-autoregressive transformer for robot following ahead. One of the important features of autonomous robots is to follow a human. There are multiple cases where it is required for a robot to follow a human from the front side, which is a much harder task compared to following behind or beside a human. For example, an autonomous suitcase, guide robotic dog, or for capturing videos. We define the problem such that a human is moving on a predefined path and the robot starts moving from different sides and keeps moving ahead of the human. We use a machine learning model to predict the human future trajectory as well as human poses to move the robot to a point ahead of the human. The point is 2 meters ahead of the future human skeleton. The simultaneous human pose and trajectory prediction can help to better understand human intent and robot path planning. For this purpose, we trained a non-autoregressive transformer model, which has 2 major parts. The upper part is for human pose prediction and the bottom one for trajectory prediction. We added a shared attention module to share the features in between the 2 sections for better modeling the trajectory prediction. Also, we added 2 end attention modules, which help for better modeling the temporal dependencies. The loss function is the sum of 2 sections mean squared error between predicted sequence and the ground truth. The model receives half a second or 5 frames as input and predicts 2 seconds or 20 frames of the future human motion. Based on our baselines, we define the tests as a straight path, S-shaped curve, and U-shaped curve. Here you can see the robot's movement based on the human's motion for a straight path for different initial conditions. Here you can see the Vicon motion capture results for the human and robot paths. On this slide, you can see the robot and human motion when human is moving on a U-shaped curve. And here you can see the Vicon motion capture results for the human and robot path. Finally, you can see the robot and human motions when human is moving on an S-shaped curve. And here you can see the Vicon motion capture results for the human and robot path. In order to show the capability of our model, we defined some extra motions for the human and tested with the robot. On the left, you can see the robot's performance for sit to stand and stand to sit motions. Here, predicting human pose helps the robot to predict the future goal more accurately. We also show the generalizability of our method by performing 2 versions of follow beside. On the right, you can see the robot following a human on the right and left sides.